Okay, good afternoon, everyone. Let me start working with um, some problem related to fluid. Okay, we have the first problem. Solute Cortep is available in 50 milligrams per 2 ml in IM solution. Your patient is given 25 milligrams of those medicine. What is the amount will you give to the patient? What is the amount that you will give to the patient? Hello, guys, are you there?
Yes, Professor.
Okay, go ahead, everyone.
I'm
Analyze.
working. Yes,
Can
and
you, huh?
Two, Professor. Two.
1 ml, Professor.
What you did? What you did? Can you explain me in your own words what you did to get solve this problem? Huh? Joseph, what you did? Who's here?
I'm here, Professor.
Okay,
They
please
have noise.
go,
But
everyone, and try to do the problem together. Okay?
okay, no problem.
Okay, let's share
We
the
can
screen again.
divide it 50 divided by 25. Can you?
Exactly. That's what you're supposed to do. Can you see the screen?
Yes, I'm here. I'm
Okay,
here. I see
we
it.
divide 60 divided by 25 and then multiply it on 2. What is the solution?
One.
As 1. Good job. It's 50 milligrams times 2 ml divided by 2, which we have 25 milligrams, and then we divided 25 milligrams divided by 25, which is 1 ml. Everyone agree? Let's go
Yes,
Yes, Professor.
Professor.
Next problem. A patient is prescribed 40 milligrams of furosemide to be administered orally. On hand is a solution that has 10 milligrams per ml. What doses should the patient be given?
It's 4 milliliter.
Okay. Good job. Next question. A patient is prescribed 25 milligrams of amoxicillin 3-hydrate clavulanate potassium. Hem is a mixture that has 125 milligrams in 5 ml. What dosage should be given to the patient?
One.
1. Okay. Good job, 2. Okay, next question. A suspension contain pentoin 125 milligrams in 5 ml. How many milligrams of pentoin are in 40 ml of suspension? Okay. Everyone got this problem? We have the pentoin
1,000.
1,000. Okay, let's check. Okay, great job. Great job. What's next question? For next question, we have a solution that contain morphine hydrochloride 2 milligrams per ml. How many milligrams of morphine hydrochloride are in 3 ml of solution? If they have 2 per ml, how many are in 3?
Oh my God.
0.67 milligram.
67?
Yes, Professor.
0.67. No.
6.
It's the option C, because we had 2 milligrams in 2 ml, in 1 ml. How many we have in 3 ml? If in 1 we have 2, in 3 we have how many? 6.
6.
6. Yeah.
Got it?
Yes.
I got it now.
Perfect. Okay, next question. A suspension contain erythrocin 250 milligrams in per 5 ml. How many milligrams of erythrocin are in 20 milligrams of suspension? We have in 5, we have 250. How many we have in 20?
$12.50. 12.5.
Huh? Say it again.
12.5.
1,000.
1,000. Because if we have 250 in 5, how many 5 we have in 20? We have 4. 4 times 250, which is 1,000. Got it?
Yes, I got it.
Yes,
Good,
Professor.
good way, guys, that we can do this one. Let's see if I can share my screen and you can see. Let me put this one, because that kind of problem, the way that that best we solve it is by using the rule, the butterfly method, or a cross multiply. Okay, let's see if I can open this one. Just hold on a second. Open this one for a second. And I will be showing you now good way to do this kind of problems. Can you see my
It's
screen?
better now. Thank you, Professor.
Can you see my screen?
Yes.
Yes. Yes, I will.
Yes, Professor.
I will be showing you now.
Okay.
Okay. Perfect. I have my graphic packet tablet connected. Okay, perfect. Let's put some colors. For example, we said, okay, we have 250. We have 250 milligram per, let me put this one in the bebop. We have 250 per 5 ml. Okay? And then the question is, how many milligrams are in 20 ml? In 20 ml. You need to get how many milligrams are. Right? This is what you need to get. You need to get how many
Yes, Professor.
milligrams. And then in that case, you just put an X here. Okay? And then cross multiply 5, X times 5, X times 5, and this one times this one. Okay? There you said, okay, X times 5 is 5X, and then 250 times 20, and 260 times 20, and then X is equal 260 times 20 over 5. Then finally, the solution for this one is 1,000 milligrams. Got it? This is the process, how we do it, mathematical way. Clear, everyone?
Yes, Professor.
Thank you.
Thank you.
You're welcome. Okay, let's do the following question. The following question said, the patient is prescribed 180 milligrams of paracetamol to be administered orally. On hand is a suspension that has 120 milligrams per 5 ml. What dose should the patient be given? What dose should the patient be given?
B.
B?
Yes.
Okay, let's check. Okay, perfect. Everyone have a question on this problem? Any question on this problem?
No, I'm okay. I don't know about the other one.
Everyone, please. Another question? I think this one is okay. Okay, let's do this one. A syrup contains chloropromazine 25 milligrams in 5 ml. How many milligrams of chloropromazine are in 50 ml of syrup? Okay. Similar question to the problem that we did before, okay? Everyone is working on it? We have a
I'm okay
25
on it.
milligram in 5 ml. We have 50
Professor
ml.
A, 250, no?
Yes. 250, let's check. Same problem, just let's do the problem for you guys. Cross multiply, and then we have 5x equal 250 times 25, and then x is equal to 50 times 25 divided by 5, and then x is equal to 250 milligram.
Can you write it for us, please?
Huh?
Can you write? Can you share the explanation?
Do you see the screen?
Yes, I see it.
What do you want? What do you want to get?
I need you to write on the screen.
What do you need specifically? The video, the link, what you want it? Can you see the explanation that I'm doing it? This one right here.
Yes, I see it now. I didn't pay attention on the
Okay,
I
let's
see
do
it.
it. Let's do it again. We have a 25 milligram. We have 25 milligram, okay, in just 5 ml. Got it? But the question said,
I got it.
how many milligrams? The milligrams, the X milligram is what you need to get. You don't know how many X milligram we have in 60 ml. Okay, and then when you state that on the problem, just do a cross multiply x times 5, which is 5x, and 25 times 50, 25 times 50, okay? And then the 5 that is multiplying, go divide them, and then we multiply 60 times 25 divided by 5, which is 250 milligram.
Thank you.
You got it?
I got
Grabbing
it.
the
Thank
idea?
you.
Okay, perfect. Okay, let's do the following problem. Let's do the following problem. We have a patient that is prescribing 5 milligrams of personalized to be administered orally. On hand is a concentrate that has 3.2 milligrams per ml. What dose should the patient be given? What dose should the patient be given?
C. 1.25.
1.25?
Yes.
Good job. You did it. Getting the concept, guys? Okay. The next problem said the patient is prescribing with a 35 milligrams of chloropromide to be administered orally. On hand is a syrup that I have 25 milligrams in 5 ml. What dose should be the patient given?
B. 7 milliliter.
7 ml. Okay, good job.
Thank you.
You're welcome. Let's do next problem. In order for the phenobarbital elixir, 15 milligrams, on hand is phenobarbital 5 milligrams per ml. What dose should the patient be given?
It's 3 milliliter.
It's 3. This is pretty easy exercise, right?
I love it.
But little by little, we're getting all of them. Okay?
Thank
Little by
you.
little.
Yeah. Okay, no
This
problem.
is a skill that we need to develop. How you develop the skill? As most problems you do, as most skillness you will be on this one. Okay, let's do the following problem. A patient is prescribing 20 grams of lactosule to be administered via gastric tube. On hand, we have a lactose of 10 grams per 5 ml. What dose should the patient be given?
Early.
Hmm?
A. A.
Okay, okay. Remember, this is divided 20 divided by 10, which is 2 times 16, 30.
Yeah, 30.
And then what is the next problem? A patient is prescribing 600 milligrams of erythrocin in suspension. On hand is a suspension that I have 400 milligrams per 5 ml. What dose to the patient is given?
Seven 7.5.
7.5. Okay, good job.
Yes.
Okay, let's see what is next. Hmm. 30 milligrams of tofranil is ordered. The available solution contains 25 milligrams in 2 ml. How much will you administer it?
Two point four.
2.4? Good job.
Yes.
Yes.
Next problem. A patient is prescribing 800 milligrams of erythrocin to be administered orally. Ham is a mixture that contains 125 milligrams in 5 ml. What dose should the patient be given?
C. 4.6.
6.4.
6.4, yeah.
Okay,
Yes, Professor.
it's incorrect.
Is that incorrect? Wow.
Yes,
Incorrect.
because the
It's
patient is
32.
prescribing
32.
800 milligrams of erythrocin to be administered orally. On hand, we have 125 milligrams.
No,
That
it's wrong.
is
It's
30.
No, no. You
32.
need
Is
to divide
32.
it 800 by
Divided
125 and then you
by
multiply.
125
Yeah.
multiplied
5.
by 5.
By 5. There is one. Okay. I got it, Professor.
Got it now?
Yes, Professor.
We got it now.
Perfect. Okay, 50 milligrams of the demerol is ordered. The available solution contains 100 milligrams per ml. How much will you give?
It's D.
0.5.
0.5. 0.5, Professor. D.
Okay,
Yes,
good job.
0.5. Yes, yes, 0.5. Good.
Next problem. A mixture contains penicillin 250 milligrams per 5 ml. How many grams per gram of penicillin are in 3 35 milligrams of mixture. Okay, we have the mixture contain 250 milligrams in 5 ml, and we need to get how many milligrams we have at 35 milligrams. Okay, same process as we did before. Okay, we have 250 milligram are contained in 5 ml,
7.1.
and then we need to get how many 35, how many milligram we have. This is what that we need to get. Okay, 7.1. No. 'Got it?
I got it.
Okay.
Yes, Professor,
The
I
problem
got it.
was that the solution they wanted, this is 1750 milligrams or 1.5, 1.75 grams. Okay? The solution they gave you in grams. The solution they gave you in grams. And then as soon as we do the exercise, we need to convert the solution into gram. That's the problem in this, that's the issue on this exercise. Everyone got this one? Okay, let's do the following problem. The patient is, a patient is prescribed 100 milligrams of morphine hydrochloride to be administered orally. Hand is a solution that I have 40 milligrams per ml. What dose should the patient be given? What dose should the patient be given?
Two point five.
2.5. Got it? Got it, everyone?
Yes, Professor.
Let's do the last question for this section. A patient is
Okay.
ordered 750 milligrams of erythrocin orally. What is the volume? What is the volume ml required if the suspension is stopped and has a strength of 250 per 5 ml?
Is B 15.
SB. Okay,
Yes.
perfect. Okay. Okay, let
Yeah,
me
he's
start.
going after.
Huh?
Sorry.
Okay, let me start with this question. A solution contains morphine hydrochloride 40 milligrams per ml. How many milligrams morphine hydrochloride are in 2 ml?
Eli.
Mhm.
Eli.
How many?
Eli. C.
80. Good job. Next question. The order is ampicillin suspension 750 milligram. On hand is a suspension that I have 250 milligram per 5 ml. What dose should the patient be given?
Fifteen.
Hmm?
15. 1 5.
Good job. Got it? Can we do next? Go ahead. A suspension contains erythromycin 250 milligrams per 5 ml. How many milligrams of erythrocin are in 10 ml? How much it is? 250. We have in 5 ml, and then in 10 ml, how many we have?
500.
500. Good job. Next problem. The patient is ordered 750 milligrams of erythrocin orally. What is the volume in ml that required if the suspension in a stop has a strength of 250 in 5 ml? Okay.
Fifteen, Professor D.
16, 16. Okay, 700 divided by 220, that multiplied times 5. Okay, good job. Perfect. Next problem. The suspension contains pentoin 125 in 5 ml. How many milligrams of pentoin are in 30 ml? Go ahead. Similar question to one of the problems that we did before. Got it? Hello? Hello?
Yes. Yes,
750.
Professor.
What is the answer for this one? The suspension contains 125.
750.
D.
What is the
750.
option?
D.
D.
Like a dog. Yes.
Perfect. That's totally right. Can we move and do another section of exercises? Or you want to do the same thing?
Let's
Okay.
move.
Let's move on the same package.
Move to another section. We're gonna move.
Okay, move to another kind of exercises.
Yes, Professor, please.
Okay. Okay, perfect.
Yes, Professor.
Okay, let's do now for injection dose calculation. Let's do some for injection dose calculation. Okay, we have a MRU team. Okay, this is the basically information that everyone need to know. The 1 kilogram have 1,000 grams. The 1 grams have a 1,000 milligrams, and the 1 milligram have 1,000 micrograms, and 1 liter is 1,000 ml. Okay, this is more or less the basic information that everyone need to get in the way to solve all those exercises. Let me start. The first problem said the patient is ordered hydroxide hydrochloride 20 milligrams. The ampoules contain 50 milligrams per 60 milligrams per ml. What volume is required for the injection?
Two point five.
2.5? No. For this problem, we divide the 20 milligrams divided by the 50 milligrams, which is 0.5 ml. Sorry. Can we move now?
Let's do, Professor.
Thank you, my dear. Next problem. The patient is ordered benzypenicillin 900 milligrams on hand is benzypenicillin 600 milligrams in 5 ml. What is the volume to be draft for the injection?
A. 7.5. 7.5.
7.5?
Yes, Professor.
Good job. Next problem. Cetriaxone 1,250 milligrams have been ordered. In stock, we have ampoules of 1 gram per 3 milligrams. What is the volume on a stop solution we need to be dropped for the injection?
Is it 3.8?
3.8. Good job. Good job. You did it. Everyone has question?
I have a question, Professor.
Yeah.
These type of problems in this website, is that something that we have access to or just you guys?
No, I can share even with you guys the link. I can share the link with all this problem that I can share with you. But I just not delivering this all those kinds of problems. I delivering many other problems related to. Okay, this is a baseline problem.
Okay.
Okay, basically problems. Even though I will be sharing. This is the link. This is the link. I highly recommend also that you can watch the the links for the section that I have been delivering before. I share those links here through the conversation that we have there many others exercises that we have been delivering. The following Saturday we don't have section, but the following week we have section Thursday at 2 and Saturday at 2. Okay? Not this week, the following week.
So you Professor, you do this as well on Saturdays at 2 o'clock?
Yes, not this Saturday, the following Saturday.
Oh, I didn't know that because I have clinicals on Saturdays. Maybe that's why I didn't know.
Okay, every Saturday I'm delivering this one except the following Saturday. And the Saturday
Oh,
before was not able to do it too. But no next one, I'll let them know the day specific that I will be doing it at 2.
okay. So that
With
means you're
another kind of problem,
okay.
not the same problems, okay?
Okay.
I will be doing it too on Saturday 24. On 24. July 24. Okay, let's do next. An adult with TB is to be given 500 milligrams of caprimycin every second day. The stop on hand contains 1 gram in 3 ml. What volume of the stop need to be dropped for the injection? Hello? ¿Dónde está? Okay, I'm on the room 503. When you come, I will come to here. All right. Okay. I was talking with the professor from nursing integration that she come do another thing too. She's outside for a few minutes. Okay, that all. Okay, someone have already this something on this problem.
I'll say 1.5.
1.5. Good
Yes.
job. Good job.
Thank you.
This is all the entire process right there. Okay.
I'm sorry, Professor. You said you're gonna put the link on the chat for us to do or
The
to
link for
practice?
The link, yes, I will be sharing with you the link.
Okay, thank you. Is it free or do I have to pay?
No, you don't have to pay anything. This is for free.
Okay, awesome. Thank you so
It's
much.
pretty good, and you have there. Let me share this one with you guys. Um, this is the page. The page is by College of Licensed Nursing Practice, and then they have everything there related to the nursing calculation. They have best practice even. They have drug calculations, conversion table, medical abbreviation too. When you have problem with the medical abbreviation, we have basically in math, all the basically in math that you need to know. Metric conversion, table of dose here, fluid injection, and infusion rate. Also, yes. Okay, also they have final examination. They have like a final test, all just related to math, guys. And we have a lot of support, and they recommended even some apps that you can use. This one that you can download your cell phone and practice when you have a chance. You can download those apps will be very helpful too for pharmacology, a medical calculator, a nurse cap, and nursing guide drop book. Those two apps would be very helpful for you too. That I highly recommend to use it for being strong on those topics. Any question? Can you see the link, guys?
Let me go check 1 second.
Okay, the link is here. Get the link from there.
Yes, Professor, I got it.
Okay. Do you have any specific questions?
I don't at the moment.
Okay, let's do some problems with the. Okay, hold on. Let's do this problem with related to. Okay, related. Okay, with tablet calculation. Let's do something with function rate. Okay, MIU team. I'm working right now on a project that I'm delivering a course totally free for all the students for the school that is related to nursing calculation that will be included in your portal. Soon that will be appearing. I'm working on it. Okay, this is IV infusion. The patient is receiving fluid from two IV lines. One line is running 65 ml per hour and the other is 70 ml per hour. What volume of fluid would be the patient receiving IV over 12 hours? Okay. Anyone have any idea on these problems?
Wait, Prof, let me try.
Okay, everyone figure out, please. Okay. Okay.
Is it 840?
840. No. 60 ml per hour per 70 ml per hour is equal to 135 ml per hour per 12 hour, which is 1620 ml. Because you give it to the patient from 2 IV lines, okay? From 2 IV lines. Everyone understand? If you given the fluid for 2 IV lines, you have to adding the running way from each IV lines, and then as soon as you add in them, and then you multiply it by the 12 hours that I go over because it's per 12 hours, and then you can see how many ml of fluid will the patient will be receiving.
Well, because the way I had did mines is I had multiply 65 times 70, since it's talking about per hour, so I had put 1 hour under, and then 12 hours is
The
so
problem is that you put a bow at the same time.
yes. Okay.
That's the problem. We got it? As you see, this kind of problem change a little bit. It's not the same as the problem before. We need to analyze some other conditions. Okay, let me do this problem, and then this problem have a condition at the end that I said the answer is an ml per hour, rounded to the nearest whole number. Which one are the whole numbers? The whole numbers are the counting numbers, like 0, 1, 2, 3, 4, exactly, okay? And then what is the required flow rate of volumetric infusion pump to deliver 1 liter of dextrose at 4% in 1/5 normal saline over 16 hours? Go ahead. Anyone with any idea? Any idea about it? Hello?
No, professor, we need help.
Okay, someone else have an idea? There is a lot of information there that we don't need to solve this problem. There is some distractors, okay? Analyze what are the distractors that we have on this problem. The dextrose at 5%, that information is needed.
4%.
Huh?
No, professor.
This is a distractor. Okay. 1/5 normal saline over 16 hours. What else? What other information? What information that is needed? Hmm? Hello? Hello?
Yes.
Okay. Do you have an idea on it?
You're asking which other information is needed besides 16 hours?
Okay, the information that is not necessary is the dextrose is at 5%. This is a distractor. But we have the 1/5 normal saline over 16 hours. And the question said, what is the required flow rate of a volumetric in function?
63.
63. What you did?
A 1,000 divided by 16.
Great job. Great job. Great job. Remember that we have in a liter, we have a 1,000 ml, and you divide it by 16 hours, and then it's 62.5. Good job. Got it?
Yeah.
Can we do another one?
Yes.
Okay, go ahead. An intravenous line has been inserted into a patient. Fluid is being delivered at rate of 42 ml per hour. How much fluid will the patient receive in 2 hours? Go ahead. Okay. The fluid is being delivered at rate. We have the flow rate at 42 ml per hour. And then how much fluid will be patient receive it in 2 hours?
84.
84. What you did?
Precious.
Okay. Good job.
Thank
I
you.
have, I have a question. Why not divide?
Well, you know what?
Why not divide? Why multiplication?
Okay. The intravenous lines have been inserted into a patient. The fluid is being delivered at rate. The rate is 42 per minute. How
Okay.
much the patient receive it in 2 hours? If in an hour, in 1 hour receive it 42 ml in 2 hours, how many mls?
Oh, okay.
Okay,
I
in one
understand.
hour, 42. In 2 hours,
So it's
84.
double.
In three
Oh,
hours, in three
okay.
hours,
So it'll be 42 plus 3 times
is
3.
to be 42 times 3.
Yeah. Okay.
Got it?
Yes. Thank you.
You're welcome. We have that's good problem. An infant is ordered 150 ml of uh, Harman's solution to run over 6 hours. The microdrugs delivered are 60 drugs per milliliter. What is the required drug rate and drug per minute? Following the same required, round to the answers to the nearest whole number. Round whole numbers as counting numbers. 1, 0, 1, 2, 3. Okay? We have 150 milligrams of Hartmann over 6 hours. Remember, always volume over time. Okay? And the microdrugs is 60 drugs per milliliter.
25 good.
Great job. We multiply the 150 ml times the 60 goras, and then we divide it by 60 minutes, which is 25 goras per minute. Guys, related to the exactly like this problem, I have been seeing a lot on the exegesi. Okay, very similar. We have to practice this kind of problem. Okay.
Thank you, Professor.
I highly recommend take attention to this kind of problems. We have a lot of related to this one. Okay? Especially for the exegesi. For the exegesi. When you finish out your program, like 10 problems very similar to this one. 10% of your test, 8%, between 8 to 10% of your test will be related to nursing calculation. Got it?
Thank you.
You're welcome. Okay, let's do this one. The physical deductive that I be to 30 ml per hour, and the IBAT candidate that has 270 ml are remaining that represent in IBBAB. You notice that it's in exactly 10:30 a.m. At what time will the function be completed? Okay, with this problem, we'll be finished for today, guys. Okay, it was my pleasure to have you, all of you, here today. Let me stop in the to type in.